Okay. Um, so one cannot prove or disprove anything by hypothesis testing. Okay, can't prove or disprove anything by hypothesis testing, and statistical tests because hypothesis testing is based on probabilities and not absolutes. So one can only knock down or reject the null hypothesis and by default accept the alternate hypothesis. If we fail to reject the null hypothesis, we accept it by default. Now, there's something called a type 1 and a type 2 error. A type 1 error is a false positive, and a type 2 error is a false negative. And these errors may occur because of bias by an observer, an instrument, memory recall, that kind of thing. Um, so a type 1 error, which is a false positive, means that you're falsely rejecting the null hypothesis, which means that you're rejecting the null hypothesis when the null hypothesis is actually true. Okay, that's called a type 1 error. A type 2 error is failing to reject the null hypothesis when the null hypothesis is false. So you fail to reject it when in fact it should be rejected. Um, Now, in order to minimize type 2 errors, you want your sample size to be less than or equal to 5% of the population size. So when you guys are doing your homework, this property is the source of some of the online questions that ask, is it safe to assume that the sample size is less than or equal to 0.05 for something? So what they're kind of asking for is the sample size of 100, is 100 about 5% of the total population? That's what they're asking there. Um, Now, the probabilities of type 1 and type 2 errors. So it turns out that the significance level is actually the probability of getting a type 1 error, which is a false positive. Okay, that's the probability of the significance level. And beta is the probability of getting a type 2 error. And a type 2 error was a false negative. So the probabilities of type 1 and type 2 errors should be as small as possible, okay, because we do not want either a false positive or a false negative. So we should make the probabilities of those two as small as possible. The significance level and this beta are set in advance and are important to sample size calculations. Now, as you've seen already, the significance level is usually between 1% and 10%, right? If the significance level is 1%, then the corresponding confidence level would be 99%. If the significance level was 10%, then the corresponding confidence level would be 90%. So it's not really typical to have a confidence level, lower than 90 or 99, right? So you're going to be seeing significance levels typically between 1 and 10%. This value beta is also usually set to be small, between 5% and 20%. 1 minus this value is called the power of the test, and it should be as close to 1 as possible. Increasing sample size increases the power of the test. So I'm just giving you like a real short surface level definition of what these type 1 and type 2 errors are. I think for the consequences of your homework, remember this part, that if it asks you on the homework, that you want to consider this. In terms of having a hypothesis test and trying to understand what a null hypothesis is, an alternate hypothesis, the standard for rejecting the null, that's equal to the significance level. I've drawn parallels here with a court of law. So the null hypothesis, for example, is that there is no association between a medication and the symptoms that a patient experiences, right? So if a patient takes a medication and has symptoms, the null hypothesis is that there's no connection between those two things. And in a court of law, an equivalent thing would be innocence, that the defendant did not commit a crime, right? There's no link between the defendant and the crime itself. There's no link between the defendant, which is the medication, and the crime itself, which would be the symptoms. So I'm kind of drawing some parallels here between these principles of statistics and hypothesis testing, and maybe something that you might have more understanding or more exposure to, which would be a court of law. Talking about a correct judgment, an incorrect judgment, and how that relates to a type 1 and a type 2 error. And the only thing that I've done here is shown a conclusion table, which has the position of, this value alpha, this value beta, this 1 minus beta, which is the power of a test, and 1 minus alpha, which is just the confidence level here. So this isn't the text I was referring to earlier, but this is kind of fleshing out, this idea of type 1 and type 2 errors. An example of a type 1 and type 2 error when it comes to rock climbing equipment, for example, would be, suppose, the null hypothesis is that your rock climbing equipment is safe. So if a type 1 error occurs in a hypothesis test of rock climbing equipment, then you might think your rock climbing equipment is not safe when it is safe. So that would be a false positive. If a type 2 error occurs, then you might think your rock climbing equipment is safe when in fact it is not. So falsely accepting a null hypothesis leads to a false negative error. So a type 2 error has the greatest consequences in this example, thinking rock climbing equipment is safe when in fact it is not. So a significance level of 5% is the probability that you think rock climbing equipment may not be safe when it is safe. So you want this significance level to be about as low as possible. Okay. All right. So 9.2 is short. We'll just leave it at that. Let me know if you have any questions.